Welcome back to this third video of the playlist. So we are doing CFA Level 1, Book 1, Quantitative Methods. And in this particular video, we are going to talk about harmonic mean. So in the last video, we have talked about several measures or methods of rates of return, like your holding period return was the first one. Second one was your arithmetic or mean return. Third one was your geometric mean return, and this is the fourth method, harmonic mean. And as defined here, that harmonic mean is a measure of central tendency. What do I mean by this? So what exactly is central tendency? So if you have, say, like a data set containing, say, n number of datas. So central tendency is basically, it is a measure which is used to represent the average or say your center of this data set, right? So this is what exactly central tendency is. And by the way, if you are confused, no need to worry about it. As we go on, we'll understand it more. So it is harmonic mean is another measure of central tendency. We have already discussed two other methods of central tendency, that is, or measures of central tendency. First one was your arithmetic or mean return. As you can see, mean is basically average. Average is like the center, right? Another one was your geometric mean return. So both of them are also a measure of central tendency. So basically, once again, central tendency is just like when you have a certain set of data and you want to find out the central value for that entire set, then you use one of the measures of central tendency. And these are all the measures of central tendency, and which one to use depends on what is the context and what exactly do you want. So based on that, you'll use one of the measures. So let's see what exactly harmonic mean is. So let's first see the formula of harmonic mean. I'm going to describe you each and everything about harmonic mean. Why is it used? How is it different from arithmetic, geometric, or holding period return and on? And why a need of another measure of central tendency? So we are going to talk each one of them in this video. So please be patient and let's first see what exactly is the formula. So imagine you have a certain sets of data, say like x1, x2, x3, and it goes on till xn. So if I tell you what is the formula for harmonic mean, then the formula would be how many numbers of data are there. You see that it is still n, so there are n number of data. So we write n as a numerator. Then on denominator, you'll just do one thing. 1 divided by x1, 1 divided by x2, 1 divided by x3. You go on like this, add, and you go till 1 divided by xn. So basically, this is the formula of harmonic mean. Alright, I hope you'll be able to remember this. Even if you don't remember, we'll subsequently see the use of this formula through examples, and also by the time you have gone through those examples, you'll be able to remember the formula. And why is it useful? It is useful when in your data set, if there are, say, some extreme outliers, then it is useful. And also it is useful when appropriate, in case in which the variables are rates of ratio. What do I mean by this? So if in case you have a certain data set and those data set contain rates, or these data set are, say, ratios, like ratios in the sense like your data set could be of different people running at different speed. So Speed is basically a ratio. Ratio is A by B, right? Any value which is depicted in this way for A ratio B is basically a ratio. Speed is defined as what? Distance by time, right? So speed itself is not a single value, but it is a form of a ratio. So when your data set is in the form of ratio or it is in the form of rate, then you are going to use harmonic mean. Or you can say in turn, when your data set contains ratios or the data set is in ratios or in rates, then harmonic mean is useful. We are going to see why is it useful in this case and also why it is useful when there are extreme outliers. Alright. So first we'll see why it is useful when your data set contains outliers. So as you can see in this first example, there are certain data which are given. So can you tell me which value is the outlier here? So the values are 1, 2, 3, right? 4, then 5, then 6, then 1000. So you have how many numbers? You have your data set contains 7 numbers. Your n is 7 here, right? 1, 2, 3, 4, 5, 6, 7, right? So out of this 7 data, which one is the outlier? 1000 is the outlier, right? So if I tell you that let's calculate the average of this. So your average would look something like this. So if you are going to say calculate average or mean return, so average return would be like your average data or mean would be like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 1000 divided by 7. This will come out to be what? This will be 3, 3, 6, 10, right? I'm just adding up here. 15, 21. So 1021 divided by 7. The value will be 1000 divided by, sorry, not 1000, 1021 divided by 7. It's coming out to be 145.857. So the mean for the data set is coming out to be 145.87. Please hold on. I'm going to explain you how is it useful in the case of outlier. So just watch and you'll come to know soon. What about harmonic mean? If I calculate harmonic mean, let's calculate harmonic mean for this data set. Harmonic mean return. So what is the value of n? N is 7, right? Divided by, I'll just do 1 divided by 1, 1 by 2. So this will be something like this, right? So 7 divided by, this will be 1, this will be 0.5, this will be 0.333, this will be 0.25, 1 by 5 will be 0.2, sorry, into 1 divided by 6 will be 1 divided by 6 will be 0.1667 and 1 divided by 1000 will be 0.001, right? I'm just doing just in case. 1 divided by 1000. Yeah. So if I add this up, 7 divided by, I'll add this up, 1 plus 1 plus 0.5 plus 0.333 plus 0.25 plus 0.2 plus 0.1667 plus 0.001. So this value is coming out to be 2.4507. So I'll divide 7 by 2.4507. So the value is coming out to be 2.8563. Just do the calculation as well. Yeah, so this is the harmonic mean. So why do I calculate both the means or central tendencies? What I wanted to show you was, you can see that because of this outlier 1000, your average for the data set has gone up to a high value. But harmonic mean value is not high, right? It is the right measure. It's just like in a country, or say in a room full of people, in a room full of say 7 people or 100 people, you'll be better able to understand what I mean to say here is. So in a room full of say 100 people, right? These 100 people, there's 100 people in a room would be earning their income, right? So usually all the people would be having similar income. One could be earning a bit more, one could be earning a bit less. But see, if I tell you, out of these 100 people, one person is say Mark Zuckerberg, right? So Mark Zuckerberg is very wealthy, right? So if I ask you what is the average income of these 100 people, it would be X value, right? But because of just this one person who is outlier, who could be like Elon Musk, or who could be like Jeff Bezos, because of that one person, the average income has gone up to say Y, which will be very, very high, right? So just because of one person, the average income has gone up. Thus, that value Y, which is the average income of the 100 people, which includes one person who is a very wealthy person, does that value Y, it really, really depicts the average income of most of the people? If I ask you this question, the answer would be no, right? So, because of some outliers, your central tendency will be wrong for the majority of the data set. So in this case, because there was this 1000 as an outlier, our average has gone up. So in these cases, when there are outliers present, one or two outliers, extreme outliers present, you don't want to use average mean, you want to use harmonic mean. So in this case, if 100 people were there, and even if Mark Zuckerberg is there or Elon Musk is there, if you want to calculate the average income or average salary of these people, you should rather go ahead with harmonic mean rather than the average mean. So the value which you get by harmonic mean, the average value, will depict the reality or will be relevant or real average income for 99 remaining people. I hope you get the idea. So this is why harmonic mean is useful when there are extreme outliers. Now let's see why harmonic mean is used when data set contains rates or ratios. So what do I mean by rates or ratios? As I told you before, rates could be like price per share, ratio is like speed, kilometer per hour, PE ratio. So when your data set is PE ratios, or when your data set is cost per unit or waste per unit. So when your data set is one of these, or could be any other ratios, then you want to use harmonic mean. Let's see why. Why am I talking about this? So in this example, if you see, like, if you drive 60 kilometers, the first 60 kilometers at 30 kilometers per hour, and then you drive another 60 kilometers at 60 kilometers per hour. If I ask you, so basically what you're doing is, the first 60 kilometers, you're driving at 30 kilometers. Let me write it properly. 60 kilometers, you're driving at 30 kilometers per hour. Then another 60 kilometers, you're driving at 60 kilometer per hour. So if I ask you what was the entire average speed for the whole journey, what was the average speed? So if you use, say, arithmetic mean, like you're using this 30 kilometers per hour, then using this two data, 60 kilometers per hour, then you divide it by 2, say. This will be like 90 divided by 2, this coming out to be. You will say my average speed was 40 kilometers per hour. Is that the right answer? It is not the right answer. Right. Why it is not the right answer? My average speed would be, you want to see the entire average speed for the entire distance. So how much was the total distance? 60 plus 60, right? How much? 120 kilometers. And how much time it took divided by time. Now if you do this, the total distance divided by the total time taken, then your average speed will come up. So as you can see, for the first 60 kilometers, you travel at 30 kilometers per hour. So 60 divided by 30. So it took you 2 hours. And this one took you 1 hour. So here, if I plug in here, 120 divided by 2 hours, then 1 hour, 120 by 3. This is how much? 40 kilometers per hour. So your actual average speed was 30 kilometers per hour and not 45 kilometers per hour. So rather than doing all this, I could have used harmonic mean in this case. So always remember, when your dataset contains rates, or your dataset is in the form of rates or ratios, you want to use harmonic mean. So let's see how we calculate this value with the use of your harmonic mean. So n is what here? N will be 2. Your n will be 2, right? So harmonic mean HM I'm going to write will be 2 divided by 1 divided by, first I travel at 30 kilometers per hour. Then x2 is what? 60 kilometers per hour, right? So 2, I can do this also. Take the LCM, 60, this will be 2, right? This will be 1. I can write it 3 by 60 is 0, right? So 2 by 1, if I take this entire to the numerator, it will be into 20 by 1. So this is coming out to be 40 kilometers per hour, right? So as you can see that the harmonic mean gives you the actual average speed or average value as we saw in this example, right? But if you just do the simple average, you'll not get the average speed for the entire distance. So through this example, you can see that harmonic mean can be used for all these rates and ratios, right? So till now, what we are seeing is harmonic mean is really useful when in your dataset there are some extreme outliers. They are also useful when your dataset contains rates and ratios. So now we are going to talk about something called cost averaging and also how it is related to harmonic mean. So if I tell you straight away, I would say that one of the main applications or usefulness of harmonic mean is in cost averaging. So let's understand what cost averaging is. So for example, what happens is, like, if you are a earned person, so assuming you are a earning person, salaried person, then you receive your salary every month. So out of that salary, suppose X amount of dollar, you invest it every month. You do, say, like SIP, right? Systematic investment plan. So you do it systematically every month. This X amount, fixed amount, you deduct from your salary and then you invest in shares. Shares. C shares, or say ABC shares. But you know that in stock market, the shares price fluctuate, right? So one time it could be say $10, another time it could be 15, another time it could be $8. Some other time it could be say $12. So the prices will fluctuate. So this, by investing X amount every month, you will be buying different number of shares each month depending on the cost. So if the cost gets high, you will be buying less number of shares, you will be getting less number of shares. If the share price go down, you will be getting more number of shares, right? That is a basic mathematics. So this concept is called cost averaging. So basically what it says is that when you invest fixed amount of money at a regular interval, regardless of the price, this is what is called cost averaging. So how is harmonic mean useful in this cost averaging? So basically, if I ask you one question that, okay, for 12 months, you have invested this X amount every month. And if I ask you, what is the average price of shares you bought in last 12 months? So if somebody asks you what is the average price of the shares that you bought last 12 months, then because every month you'll be buying different number of shares, right? But you want the central one value, average price of the share. So in that case, harmonic mean will be very, very useful. So in this case, let's just see with the example. So you invest $1,000 every month for 2 months. Main question here is what is the average price of your share? So let's calculate the average price of the share in a very basic way without using the harmonic mean, and then we'll see what result does our harmonic mean gives. So basically the first month you see that the price of the share was $10, right? And how much you invest? 1,000. So how many shares are you going to buy? You invested 1,000 and price per share was 10. So you basically bought 100 shares, right? So I'm going to write here 100 shares. You bought 100 shares. In the next month, how much money you invested? $1,000 again. But the price of the price per share was 15. So how many shares you bought? I'll just do calculation in my calculator. 1,000 divided by 15. So you basically bought 66.6667 shares. But you cannot buy shares in decimal value, but let's assume that you bought it, alright, for the sake of calculation. So you bought this many shares. So if I ask you how many shares in total you bought, so in total you bought 166.6667 shares in 2 months. So if I ask you what is the average price of the share, average price per share is how much money you invested? 1,000 plus $1,000. This is the total money that you invested divided by the number of shares, 166.6667. So if I do 2,000 divided by 166.6667, $12 per share. So this is the average price of your entire portfolio in last 2 months. average price per share of your portfolio, right? So we used it using our basic mathematical concept, but if I ask you how we are going to do this calculation, or if I ask you what is the average price of your share, then you can straight away use Harmonic Mean. So if I use the formula for how many months, 2, right, divided by 1 divided by 10, this value, plus 1 divided by 15. So you can write 2, 1.1, that's 1 divided by 15, you can write 0.0667, or you can say 2 divided by 0.1667. Let's see how much the value is coming out. 2 divided by 0.1667, 11.9976. So basically you can say it is 12, right? So harmonic mean is also giving you the same value here. So instead of doing all these calculations, you can just do harmonic mean. And one feature or one drawback of harmonic mean, I would say, is that harmonic mean does not work on negative number. So let's see. If I tell you that in year 1 you get 50% return, and year 2 you get minus 50% return. So the average would be what? Plus 50 minus 50 divided by 2, so 0 divided by 2 is 0, is free. But as I told you, arithmetic mean also does not give you the real return. Geometric mean will. But we're not going to calculate geometric mean here. I just want to tell you or I just want to show you that harmonic mean will not work on non-negative, will not work on negative number, right? So let me clarify something here. Harmonic mean only works for non-negative number. What do I mean by this is that harmonic mean does not work on negative numbers. So harmonic mean does not at all work on negative numbers. So if your data set contains negative number, then harmonic mean will be useless. So in a way you can say that harmonic mean only works on non-negative number, that is positive number. So here in our data set there is one negative value, so harmonic mean should not work. So let's see. So if I use harmonic mean, if I calculate, then there are two data sets, so 2, 1 divided by 50, 1 divided by minus 50. So this in turn will get minus 50. So 2 divided by 50, I take the LCM, 1 minus 1. So 2, 0 by 50. This will be 2 by 0, right? So anything divided by 0 is, in mathematics, we cannot define it. So it is undefined. So it does not hold. What if I change the value? So in first year, your return was positive 40%. In second year, the return was negative 60%. So in reality, suppose assuming you invested $100. So after first year, you must have received a return of $40, right? So $140. Then there was a deduction of 60%. So if I do 140 into 60%, then 60% of 140 is 84. So you lost $84. So 140 minus 84 will give you $56. So at the end of year 2, you saw that your $100 has now become $56 if you say hold it for 2 years. So you have your ultimate return was negative 44%, right? So this is the actual return. Actual return. But supposing if I use harmonic mean here, so if I use harmonic mean, 2 divided by 1 by 40 minus 1 by 60, right? So this is going to give 1 by 40 will be 0.0250 minus 1 by 60. Let's see what it gives. 1 divided by 60. It gives 0.0167. Now, I'll just subtract 0.025 minus 0.0167. So the value is coming up to be 0.0083. So if I divide 2 by 0.0083, this is coming out to be 240.96. So what does it depict? So this value that you are getting is unrealistic, wherein in our actual case we got negative 44% return, and this is depicting a positive return that to this high value. So this data basically is useless. So you can see that when there is a negative figure in your value, harmonic mean is going to be useless. Alright, so just remember this. I'll again repeat. Harmonic mean is useful when there are extreme outliers. It is also useful when your dataset contains rates or ratios, but it is useless when your dataset contains any negative value. Alright? Now we are going to see the relationship between arithmetic mean, your geometric mean, and harmonic mean. So there is a formula which relates them. I'm going to write it down. You just have to remember it. So arithmetic mean, if you multiply it with harmonic mean, then you'll get geometric mean. With this, you'll have to square it. So this is the formula which is very important that you need to remember, because in exam you will be given certain data like this, as you can see in the next question, and you'll be asked to calculate each one of them. So what you can do is you calculate whichever two is the easiest. Say arithmetic mean is easier to calculate, and you can either calculate geometric mean or harmonic mean, and the third one you need not calculate. You just use this formula and then you will get the third mean, either your harmonic or your geometric mean. So let's see the next question. So I'll just read it out. Each year in December, a security analyst selects her 10 favorite stocks, which are these, for the next year. So below table represents PE. PE is PE ratio basically. So PE is basically the price of the share divided by projected earning per share, right? Price divided by earning per share. So this data is your PE ratio. Now you just want to calculate the arithmetic mean for this 10 stocks. So it will be very easy. What you are going to do is arithmetic mean is going to be 22.29. You just add it up. 15.54, 9.38. So you just add it up. till the last stop, 8.35, right? If you divide by how many stocks are there, 10 stocks are there. So I'll just use my calculator. I urge you to use yours as well. We will just add it up. 22.29 plus 15.54 plus 9.38 plus 15.12 plus 10.72 plus 14.57 plus 7.2 plus 7.97 plus 10.34 plus last is 8.35. So if you add it, it's coming around 121.48 divided by 10. So this will be 12.1480. So arithmetic mean is 12.1480. What about harmonic mean? Let's also do harmonic mean. So harmonic mean would be, I'm just going to write HM. How many numbers and how many stocks are there? 10, right? 10 divided by, we just do 1 divided by 22 point this one. Then 1 divided by this, like this. So 1 divided by 22.29 plus you tell 1 divided by 8.35, right? So this will be 10 divided by, let's see. So I'll just calculate it here so that it's easy to see. So I'll just 1 divided by 22.229, right? So I'm just going to write the values here. Use your calculator. 1 divided by 22.29. It is coming to be 0.0449. Now 1 divided by 15.54. This value is coming out to be 0.0644. Similarly, you go ahead. 1 divided by 9.38. This one is 0.1066. 1 divided by 15.12. This is 0.0661. Now 1 divided by 10.72. This one is 0.0933. 1 divided by 14.57. 0.0686. Now 1 divided by 7.2. 0.1389. 1 divided by 7.97. 0.1255. You can skip it. 1 divided by 10.34. 0.0967. Lastly, 1 divided by 8.35. This one is this value. So if you add the entire thing up, let's add it up. It will be 0.0449 plus 0.0644 plus 0.1066 plus 0.0661 plus 0.0933 plus 0.0686 plus 0.1389 plus 0.1255 plus 0.0967 plus 0.1198. So if you add this entire thing up, the value is coming up to be 0.9248. I'm going to write it in 0.9248. So the harmonic mean would be, this was 10 divided by, how much was the value? 9248. 9248 point, right? So divide 10 by 0.9248. So the value is coming out to be 10.8131. So this is the value of harmonic mean. And now if you want to calculate the value of geometric mean, you already know arithmetic mean into harmonic mean is equals to geometric mean square, right? Arithmetic mean was how much? 12.148. So this was over it 0 into this is 10.8131 geometric mean square, right? If I can also write it like this, GM square is equals to 12.1480 into 10.8131. So this is the value of your not exactly geometric mean. Now I just have to do geometric mean is equals to square root of 131.3575. Or I can write it like this, 131.3575 to the power 1 by 2, right? Or instead of this, I can write it as 0.5. So you type this 131.3575, right, in your calculator, and press y to the power x. There's this button. After you press it, just press 0.5. So we get the value 11.4611. So this is basically your value of geometric mean. Now we have seen the relationship between the two central tendencies, your arithmetic mean, your geometric mean, and the harmonic mean. We are also going to see two other means, and this I'm going to keep it very short. One is called trimmed mean and another one is called Winsorized mean. So basically, as the name suggests, trimmed mean. So when there are these two means are basically used when there are outliers, or I would say extreme outliers. So when there are extreme outliers, then you can use these two means also instead of harmonic mean. So as the name suggests, the first one, trimmed. So you're basically going to cut off, you're going to trim the data set. So it removes fixed percentage of the smallest and largest observations before calculating the average. So suppose if there are say 100% of data, or say like 100 variables or data, and what you're going to do is that out of those 100 data, each one of them, one could be say 2, one could be say like 10,000, one could be say 1 million, right? You just guess it. So there could be some this 1 million and also this 2 could be like, this could be the lowest figure, this could be the highest figure. So basically what I'm going to do is like, I'm going to cut a certain percentage. So 2 and 3, if these are two numbers which are very, very low in value. So I'm going to cut these two values. So two values are basically 2% of your entire data set. So you're cutting 2% of the smallest. Similarly, largest, right? If you're just cutting this 1 million, you are cutting 1% of your observation. You are removing it. So let me not complicate it, but rather let me tell you this way, that in trim mean, you're basically deleting the outliers. Okay, to sum it up, we're basically deleting the outliers, and these extreme outliers. These extreme outliers could be the lowest values or the highest values, right? So if I give you an example, if there are if this is the data set, say 5%, 7%, 8%, let me write this as 2%, then 9%, then 10%, another one is 75%. So you can see that this one and this one is like an outlier. This is not an extreme outlier, but this one is extreme outlier. So basically when you calculate the mean, you are just going to remove this. You're not going to use this. And you also say remove this one. So you're going to basically delete these two datas, and remaining ones you use it to calculate your average. Right, you do. So this is basically your trim mean. What about Winsorized mean? In Winsorized, you are not going to delete. Does not remove or delete extreme values. So what it does is, like in the above figure, you are basically going to 7, 8, 9, 10, and 75, right? So instead of replacing the extreme value, instead of deleting or removing it, what it does is that it replaces the extreme value with the nearest remaining value. So instead of 75, I'm going to replace it and say make it 10. So I'm going like 2 plus 7 plus 8 plus 9 plus 10 plus another 10. Then divided by 6, because there are in total 6 values. So this is how you are going to handle the outliers in your data. And coming to the last topic of the question, the key question I would say, because you have seen a lot of returns and lot of measures of central tendency, basically your arithmetic mean, geometric mean, and harmonic mean. And you also saw their application, how to use them, when to use them, right? So coming to this key question, which mean to use in what circumstance, is the most important question that you would be asking yourself when deciding which mean to use. So it depends on several factors, okay? And you already know it, but just for the sake of revision, I'm going to tell you again. So basically you collect a sample data, right? You collect all your data that you need, and say your data contains all the values, right? And it also includes some outliers, but it does not include extreme outliers. So there are no extreme outliers, but just some outliers. So in this case, when you want the answer, or when you want the solution or result, or you want a central tendency as fast as you want, because there would be several data, right? So you can use arithmetic mean. But suppose your circumstance involves compounding of the data. So whatever observation you have collected, not calculated. So whatever observations or samples that you have collected, if your situation or your context or your circumstance, if it involves compounding, then you cannot do simple arithmetic mean, right? Your collected data could be like past 50 years of return of stock market of a particular equity or a particular shares, right? So you're getting the data in such a way that minus 10 in like 50 years ago, then 49 years ago it was like plus 15%, and then 48 years ago it was like 28 plus 28%. So this is for one equity, then another share 2. So if your data is like that for a particular industry or something like that. So if it involves compounding, then you cannot simply use arithmetic mean. You have to use geometric mean as geometric mean return, as we have discussed before as well. Now, if your dataset contains not just some outliers, but say extreme outliers, and because there is a presence of this extreme outlier, it is going to impact. It is basically going to, because these extreme outliers are there, it is going to impact your data or say your result. And when you want to calculate the central tendency for majority of the data set, but because of this extreme outlier, it is going to distort that result, right? So as I gave the example of those 100 people in a room, and one person, say Jeff Bezos or somebody who is very rich, and you're trying to find the average income or salary of these people, of these 100 people, average annual income. So just because of one person, the value or the average income is going to shoot up so much that you are going to say that each one of them is very rich, right? Which is not the true case. So in this case, you cannot use a arithmetic or geometric mean. So in this case, you can use a harmonic mean, or you can use trimmed mean, or you can use a Winsorized mean, right? So these are the all returns that are there in the book. And there is another example which I'm not going to do, because even if I give it, the video is going to be very long, and it's very simple. You're given some data set and you're just asked to calculate arithmetic mean and also geometric mean, which you already are well equipped with. So in the next video, we are going to talk about money weighted and time weighted returns. So stay tuned, and if you like the content, please do hit that subscribe button and let me know what else you want to learn, and if there is any confusion, just comment down below. So see you guys in the next video. Thank you.